Okay, so we're going to continue talking about, after you've inherited. We'll now talk about access modifiers. So for classes, we could put modifiers, and this is again on the topic of access to variables and methods. We could say a class can be public. We could say that a class can be abstract, which we've talked about. And a class can be final. Okay, so just a review. What was a final class again? Right, so remember, any class we create, generally it means that somebody else can create a class and extend from us. So extending means somebody can inherit from us. But if we said a class was final, what would that mean? Well, no, actually some of these words are going to show up under different categories, and it would mean that.
Oh, we are classes.
Yeah, so in the case of a class, if a class is final, that would mean that no other class can inherit from it. If you say extend a class that is final, you're going to get a compiler error. Abstract, like we said, is a class that cannot be instantiated, but it might have a purpose in your design that, like for example, when we had, I think we had a class called shapes, which was an abstract-based class, and then we had circles and squares and triangles, which inherited from them, and they actually used the methods that were defined in the abstract class. Class can also be public. Now here's the thing, would you expect there to be a private class, such a thing as a private class? And actually the statement that all classes have to be, what we're saying here is that they can't be private. That's not actually true. But does the idea of a non-public class make sense? So you know how like when you create an object, you say, let's say we had a class called my class. So you would say my class, C, MC, equals new, my class. And we create one of these. What if my class was defined as private? The entire class was private, not a variable, not a field inside the class, but the actual entire class was private. So does even the concept of having classes public or private or protected even make any sense? Should they just all, why would anybody declare a class that's private, meaning it's a class, but I don't want anyone to ever be able to use it? What good would it be? So a topic we'll talk about a little bit later on, we can actually have nested classes. We can have a class and then defined inside the classes other classes. And this might come up in a data structures class where you have an outer class called data structure and then inside it a linked, a node to a linked list. But you don't want people outside of the data structure world to have direct access to the linked list, the links on the list. So you can make the linked list subclass private. But in general, what we're just saying now is we're recapping. We'll say that classes can be modified as public, but right now we're just saying not private. Okay, now constructors. Constructors can be public. And if you remember, we said you don't even have to say that because it was understood to be public. But we could make a constructor private. Now, what would happen if you made the constructor private? Suppose somebody came along and, again, said, my class, MC equals new, my class. This says, create a brand new object of type my class, then run the constructor before you return the storage to have this refer to it. But if the constructor was private, you couldn't run the constructor, right? So it sounds like the same argument. Why would we ever have a class that's not public? No one could ever use it. Now suppose we had a public class, but a private constructor. What value would that have? Would you see it? Can you think of any reason? This is something we'll talk about towards the end of the course, but there might be a case where you want to have a class, you want a class to exist, but you don't want anybody to create an instance of it, a particular object of it. Like maybe an example you might make sense right off the top was, suppose you had a class that was like a database connection. So you want to connect to a database. You create a database connection object, and then you use that object to connect to a database. Well, someone can come along and make 1,000 of these, and they could all connect to the same database. But maybe the database only wants, it's configured to only have 10 connections, maximum, at a time. Well, if you let the constructor be public, you have no control. There could be infinitely many connections made. You might want to control it. So let's say, for example, we decided, and like I said, we'll talk about this later on when we talk about design patterns, but if we wanted to have just one instance of a particular object ever created, a maximum of one at all times, we can make the constructor private so nobody can create those, and then have one static instance of the class, one for the entire class, and then everybody share that one. Okay. And then similarly, because we might want to keep it private so nobody can create one, but we may be inherited from, so we might also want to have a protected constructor. That's possible with constructors. Now there's also a distinction between local variables and then fields. So within a class, we have variables within the class. If you create an object, every object gets one version of that, what Java likes to call fields. So there's one for every, fields that appear in every object. If you have a method, and in your method you have a for loop for I equals 1 to 10, that variable I is not, it's not one copy for the class. It's not a field variable like there's one for every object you create. It's just a local variable while that method is running. It only has scope inside that method. So as far as local variables are concerned, we can have a modifier of final. And they say it's good practice to always use final, but so that way nobody can inherit from it, but those variables couldn't be inherited from anyway. So, and then as far as field modifiers, there's a collection of for fields. These would be fields like variables within our class. So we could have public. Like what, just off the top of your head, what do you think there would be? So these would be variables within our class. These are the ones that could be inherited or could be used by the outside world, or maybe we don't want them being used. So we'd have public and private. Since they are inheritable, they could be protected. Anything else? Since they're inheritable, we may want to, does the concept of having a final variable, a variable have a modifier final in front of it, what would that mean? That would mean, if a variable is final.
It's constant.
Yeah, so, right, so there's a difference between final like we had up here, where a class is final means you can't inherit from it. If a variable is final, you're gonna inherit it, but you don't want the inheriting class to then be able to change its value. No. So it would just be that it's like a constant. It would just be whatever if we had a variable, an integer, that was final, and we set the integer equal to some value like 3, nobody should be able to change it later. So if we said, for example, final int x, and then said semicolon, what do you see being wrong here? So final means the value has been set and nobody should change it in the future. Nobody could later on come along and say x equals, x plus 2, because that would change it, and it's final, so it's frozen. What looks wrong if you say final integer x, and you don't give it an initial value? It says I can't change. I'm not setting it to anything. It would actually be set to 0 because it would default to 0, and nobody could change it. So generally, you set it equal to something and then it stays. Now think about this from a compiling point of view. If you were designing the language, would you use up a chunk of storage, call it x, store 3 in it, and then somehow put a lock around it that it can't change? Or, I mean, this is very similar to what C and C++ call a constant. They actually have you could say this in C and C++. And that means it doesn't change. It's a constant. But you don't actually, the compiler doesn't actually have to take up any space. It just knows from that point, from that declaration on, as long as that variable is in scope, everywhere you see an x, you just know that's a 3, and the compiler could just put a 3 there. So it doesn't actually have to use up space, because it won't change. Okay, and then we also talked about fields can be static. And remember what static meant again? Static meant there would be one variable per class, not one variable per object. So for example, if we had the ratio, if we had a class that had a ratio had a numerator and a denominator, but suppose there was a third variable called count, like how many ratios are out there. So if we created 5 ratios, we want the count to be 5. So let's say we had a ratio of 2 divided by 4, and another ratio 0 divided by 1, and a third ratio 2 divided by 5, and then we had one variable called count, and that says there's 3 of them. Well, it's not like every ratio has its own count. It's not like they all have their own personal count field, and we're incrementing their counts. We just have one for the whole class. One variable for the entire class. So this is a class variable, and then these are 3 different instances of it. So class variables are of type static. There's 2 other field modifiers, but that has to do with fields being volatile and transient, and that has to do with multi-threaded programming. So we'll revisit that when we hit multi-threaded programming. Okay, so then method modifiers. What method modifiers do you think there would be? So this would be what you put in front of your method. So can methods be inherited? If so, would you want to have some methods that are not inheritable and some methods are inheritable? If so, that would probably open the door to having public, private, and protected. So just off the top of your head, what do you think, what are some method modifiers you think would be allowed? So should a method ever be public? Meaning can be used. Right, so somebody creating it. Okay, so we can have public methods. Would it make sense to have a private method?
It's modifying.
Was that?
I don't think you're modifying, I don't know.
Yeah, so that means you wouldn't be able to use it. Well, you wouldn't be able to use it directly. So for example, if you created an object, X, and then said, print value. In order to call the print value method on X, the print value method would have to be public. But if this was code outside of the class. So if we had a method that was private, you couldn't call it. You would get a compiler error. But what could what could call it? Another public method. So if there was ever a scenario where you have a public method in your class, and that public method needed some task to be performed, so you decided to make another, and you didn't want to put it in the body of your method, you wanted to make a separate method, you could have a public method in your class, call a private method in your class, perform some task, it returns a number, and then your public method uses that. You know, like let's say for example, you had some class that had mathematical functions, and you needed to calculate the square root of a number. To perform the function the public method wanted to do, you had to calculate the square root of a number. So you decided to write a separate method in the class just to calculate the square root of a number. But you don't want the whole outside world to be able to use this new square root method. Only your methods inside your class should use it. So you create your own private method, and then methods in your class can use it, but nobody else can. So they allow this. A lot of these decisions, there was just a board of people getting together saying, should we allow this, should we not allow this? So they decided to allow private methods. Now, if you have public and private, and the thing can be inherited, you're always going to have that hybrid class of protect.
It has to be within a public method, right? Private.
Right, so I guess, you know, it would probably be a good, what would be the trick question, like a test question? The question would go something along the lines of, is there any point to a private method if it is never called by a method that is never called by a method, you know, until it eventually gets called by a public method? Like if you created 3 private methods in a class and no public method ever called them, they call each other, but that's it, they wouldn't have any use because the outside world could never trigger one to be called. You always need like one public method to then call a private, which could then call another private, and so on. But so what would be good ways to phrase that trick question? Like, what if you had a class that had 100% private methods? Would that class ever serve a purpose? Would any of those methods ever serve a purpose? I think the answer is no, because nobody could ever use them. That's a good question to think about. Could you ever use, if you had a class and all the methods were private, could you ever call any of the methods? No, it looks like you need to have at least one public method, and then that one does the other calls. So what other, now, we talked about abstract classes. That's where we say we declare this class as abstract. But we can also declare a method abstract. And that will force any class inheriting an abstract method will be forced to write the body for it. Otherwise, the method remains abstract and you can't instantiate that object either. Okay. And what if we had a final method? We had a method called print value and made it final. If we made the method final, print value, what would that mean? Now, we've already seen 2 definitions of final. One is applied to an object that says it can never change. The other one is where we say final, meaning you can inherit it. Now, if a method is final, so on an object it means you can change it. For a class means you can inherit the entire class. Here is a method, so it's from a class you can inherit, but the method is final. What do you think that would mean? This is now a 3rd definition of the word final. If a method is final, does that mean you can't inherit the method? Well, you inherited the class, you're going to get all the methods. So you're going to inherit the method. but what would it stop you from doing? Final means it's like stopping you from doing something afterwards.
You shouldn't be able to overwrite that.
Right, you couldn't say, okay, I don't like this print value, I'm gonna write the new version of it. So it means it's final, so it can't change. So I have three different definitions of the word final. It's a keyword in the language, but it's used three different ways. And then synchronized methods are a topic that will also be in, a topic that will also be covered in when we talk about multi-threaded programming. Okay, so when you inherit from a base class, if we have a base class and a derived class, and you inherit something from the public section, the stuff that is from the public section in the base class goes to where in the derived class? Actually shouldn't use the word section because it makes it you think the storage is being moved somewhere, but it's the access. Anything that has public access in the base class will have what access in the derived class? So this is kind of an intuitive question, but if you had a public field, like public int x, if we had a class base with a public int x equals 2, and that's it, and then class derive extend base is int x public in D. Right, so if it was public in base, it becomes public in derived. So stuff that is public, I'm just going to draw a little chart here, stuff that is public becomes public in the derived class. Stuff that is protected, well, default was a little bit more vague, so stuff that was default. And remember, default was you can inherit default and anything in the same package has access to it. It's kind of like that friends concept in C++. The stuff that has default access in the base class will have what in the derived class. That would also come over in the default section. And the protected is fields and methods that the outside world cannot access, but you can inherit it. The inheriting class will pick it up. And remember, that's what protected was added for. Private stuff does not get inherited. So the access would be for protected stuff. In the derived class would also be protected. Now, so here's really what the question comes down to. Would you ever want to put these somewhere else? So let me just write this out. And the stuff that is private goes where? The stuff that was private in the base class goes where in the derived class? I keep saying goes where. I don't want you to think it's stored. Stuff that had private access, meaning anybody outside cannot access it. How can it be accessed? What is its access in the derived class? You can't access it, right? So not accessible. Not accessible. Okay.
So would it be a compilable error? Like if you do that, right? If you try to add it.
If you tried to access it,
Right.
you would get a compiler error. So let me just I just want to point out something C++ allows, and Java took this out, and I'm not even sure why they took this out. I don't know if it's just because it has too much confusion. But so let's just kick around the idea for a little while. Would you ever want to allow the access to the inheriting class to be changed? In other words, like, suppose you have a base class and it has a public field in it. Would you want to be able to say, I want to inherit it, but I want to move the public stuff somewhere else? I want the public stuff to become, protected. I want to inherit all the public stuff, but I want to reassign it to protected. Or I might want to take the private stuff and I want to inherit it and move it to the public section. Can you think of a reason why you might want to do this, or you might never want to allow anybody to ever do this? Like any just open discussion on this. What would be a problem if you were able to, like these were listed in loosest access and tightest access. What would be the problem of making the access looser? Like, do you see any issue with that? Somebody creates a class, they have fields that are private. The outside world should never have direct access to them. You inherit from them and promote them to public. Any danger there?
Just open everything wide.
Yeah. The whole design just got opened, right? They want you to use the class. They want you to only use the public methods they supply to you, nothing else. You come along and say, I'm going to start moving stuff around. So actually, and this would be true for anything, from protected to public, any kind of a promotion, anything where you make it less, the access to be looser. That you would never want. But you might be in a scenario where you might want to make it tighter. And in the C++ language, you can do this. You can say, I want everything from these 4 classes to be no higher than protected. Meaning public becomes protected, protected becomes protected, and then private doesn't get inherited. They actually allowed this. So in C++, and I'm thinking, we're not learning C++, but it's just something to think about. They allow you to do this. You could say, so the Java version would be class derive extend from base. That's how you would declare class derived is inheriting from base. C++, the equivalent would be class D, 2 dots. So Java took out the 2 dots and put in the word extend. No big deal there. But then you could say private B, or you could say public B or protected B. So it changed some of those arrows that we just had before, and it said you couldn't make them go upward because for design reasons you're overexposing a class that somebody else created. But you could make them go downward if you wanted to. And the creators of Java decided not to do this. They don't want you. They just wanted to go field for access for access. So now the question is, suppose you had a class, suppose we had a class, base, which had a protected method. Yeah, let's just, now that we just kind of saw what the rules are, let's just think intuitively. Suppose we had a method called let me go over one example. Let's say we had a private field x equals 2 and a public method print x, which is a method that does this. Okay, so we have a public method that prints X, but X is a private variable. And now we have a class D, which extends D. And it doesn't do anything. Now, later on, in our main program, somebody goes and creates an object of type D. Creates an object of type D. Let's see, did I set up the trick question for everything? And they call D's print X method. What would you expect to happen? So, just a little review. We have a base class, class B, has a private field X, and a public method print X. So obviously if you created an object of type base, you couldn't do this. You couldn't create an object B of type base and say b.x equals 5, because you're not allowed to directly access X, it's private. But you can call the method, print X. And that'll print out a 2, because that method's public. The method has, because it's inside the class, has access to this field X. The method does, but you don't. Now, D extends B. What does that mean? Well, everything that's public gets inherited into the public section of D. Everything that's private does not get inherited. So there is no X as far as D is concerned. But there is a method print X. And what does it do? Well, it has the right to look at the X field and print out its value. So if we did this, if we created an object of type D and called print X, the print X method we inherited is public. What does it do? It prints out X. But there is no X. If you were designing the language, what would here's what I guess what the question comes down to. Is there an X there that we have no access to, but we need it there because public methods may be accessing it? Like we were saying, it's not a field that is part of D, or is it? Is it a field that can't be accessed, or is it a field that, or is it not there? So how would you, if you were designing language, how would you handle this? Would you say, would this have a runtime error? Because this went to print a variable that, oh, at runtime you realize it's not there. Or would you let this be a compiler error? Or do you let these private fields, like we've been saying, private fields don't get inherited. Would you let them be there just in case some method that was public referred to it? So there's really 3 design choices. Would you let it be, would you want it to be compiler errors, so you're telling the person you're doing something wrong, rethink what you're doing? Or do you want to inherit the X field, but you just can't access it? That way, if somebody needed it, it comes along for the ride. See, so does anyone think you would make it a compiler error? Yeah, I guess the reason they've decided not to. So we inherit the X, we just can't access it. So when I was saying before, like the public fields go into the public section, the protected go into the protected, and the private become inaccessible. They're there, you just can't access them. But they're there in case some method that does access them need them.
It would still print X.
It would still print 2.
2, yeah.
So there is, in this D object, I guess this is the point I'm getting at. The D object has an X field that is called, that is set to 2, but even inside of a D, if we had said inside the D, if we had said, what's a good demonstration? Suppose we overwrote this method and we said public public void print. This would get a compiler error. Print X, and it said system out print D's version of X. Right, instead of just printing X, I want to print D colon X, you know, I want to make it somewhat different. This would get a compiler error because even though we're inside the D class, we can't access X because it never got, its accessibility never got inherited to us. But the base method could access it. And I guess the reason for why they allowed that is, suppose we didn't put this method in, we just left it the way it was, we would now get these unexpected compiler errors, because now we would, the new rule of thumb, if we decided, since X is not inherited, any public method that refers to it can no longer compile if you inherit from, in other words, if you were to design the language so that this would be a compiler error, the rule of thumb would be, we can inherit public methods, but any public method that makes a reference to a private variable will now cause a compiler error. And then you'd have to tell programmers, be very careful not to have public methods refer to private data, because then nobody can ever inherit them, they'll get compiler errors. So they had, if you think about it, like I don't like having to memorize things, so try to think about it logically. If you had a rule that says public methods that refer to private data cannot be inherited, because the inheriting class might call the method. The inheriting class might call printx. Printx refers to private data, and the private data never got inherited. If you said that's going to start causing either compiler errors or runtime errors.
It probably would be a runtime. Like it will compile.
Right, I mean, yeah, I guess the topic I'm trying to get at is, logically you would think there would be a runtime error, because this should compile. Printx is a method, we should be allowed to call it. Only at runtime do we realize, oh, we're trying to print a variable from a D object, and the D object never got the variables. So we're trying to print something that doesn't exist, and you'd have a runtime error. If the language did that, so an intuition almost would tell you this should be a runtime error. But actually, if that was the case, then there would have to be a rule of thumb all the Java developers would have to learn. Don't ever have a public method refer to private data, because someone may inherit from your class and then have a runtime error. And that would be too messy. So what's really happening behind the scenes is, this variable, this private variable is being inherited, you just can't access it. Well, then you might think, then why inherit it if you can't access it? Well, there might be methods you inherit that do access it, and those ones can continue to access it. Okay. And then what if we had an example where what if we decided to overwrite this method, but change its access? Would you, if you were designing those programming languages, would you allow this? Suppose I decided we're inheriting this method printx, and it's public. Suppose I decided I want to change its access, so I'm going to rewrite it, but I'm going to change its access. So suppose I said private, and we could code this up and just run it and see if we get a compiler error. But suppose I did this same exact method, I just changed its access. Oh, but no, I can't even refer to it. Let me make this public just to make this point. Okay. Okay, so now what we've done here Would you allow this if you were designing the language? I've moved X to now become public, so now it's open to the whole world. We inherit, in D, we inherit a copy of X that we can access. We had a public method called printx. Takes the value of X and prints it out. In the inheriting class, class D extends B, I have the same exact method. So really I'm just overriding the method. And it even does the same exact thing. It prints out the value of X. That's the reason I made it public, because I want this thing to be able to have access to it. But what have I done here? I've taken this method which I inherited, which was public, and I'm attempting to convert it to private.
That would run.
Yeah, that one. Should.
Would you, well, if you were designing the language, would you let people do this?
Yeah.
Anyone think of a reason why you wouldn't allow this? It's kind of a reverse of the logic you said. Before we had a variable that was private and we were opening up to the world, and we don't want to do that, but could this break anything?
Yeah, if it's private, if you make it public into a private, I mean, it's the person already can see that number. So it doesn't make sense if you extend it and then make it private.
Coming from the public.
Well,
It doesn't break anything
Yeah,
per se, because it's not like you'd be able to actually really call that method to do anything with it, being that it's private. You would have to have another public method to call it to have it be able to not do anything.
well,
It would be able to do something, because.
well, what if we did this? What if we created an object? Now remember, we have a base class and a derived class. We can have an object of type B. Little b equals new new d. Remember, this type mismatch is allowed. We can have a reference of a base type refer to an object that is of the derived type. That's allowed. Now we can't call derived methods because the base doesn't know about them. So if we had a derived method like public void derived function which does something. We couldn't use a base object. We can't do this. We can't say b dot derived. Derived function. We can't call that. Even though b refers to a derived object, the compiler doesn't know that. All the compiler knows is this thing is referring to something of the base type. It can call base functions. It can't call derived functions. Okay. Now, suppose we took a base reference referred to a derived object and so here's kind of the answer. So does everyone think this should be allowed? Wait, where is it? This one, where you change a public method, and make it private. You should give the software developer that freedom.
Honestly, why not? Why would it make it
Well,
private?
here's the example. Suppose you then later created a derived object but used a base reference to refer to it. You should be allowed to do this. Base dot printx. You should be allowed to do that. That should compile, right? Because a base object has a method called printx, which is public. So this should compile. But at the moment, this is referring to a derived object. The compiler don't know that. You only know at runtime. So this will compile, but at runtime this should not run because this has now been converted to a private method. So what they don't allow is they don't allow you to change the access. So you can inherit a method, you have the choice to overwrite it, but you can't make its access tighter because that could cause code that's loose, like this, where you're using the base reference to refer to a derived object. You're now calling a method which you don't have the access to do. So you can't make a method's access more restrictive, but you can make it less. So for example, and I don't, this is what, like, this is what your intuition was saying they should allow you to do. This one you could never get hurt. If we had a protected method, and then inherited it and decided we want to open it up to the world, we can make it public. Now everybody could use it. And no code that was already written could ever break. We could never have a case where a base reference was referring to a derived object and called the method, but because of this change, the method won't work. You're allowed to make the method's protections more loose. That'll never hurt anything, but you can't make them tighter, because that could break code that used to compile. Okay, so again, I don't like memorizing things, I just like to have the logical reason for why it should work and not work. Now, just because it can work, just because we can take a protected method, printx, override it, and make it more useful, whether that's something a person might want to do or not is their choice, but at least the language lets you do it.